Hey everybody, it's been a couple of weeks since I've had any time to really do anything with the old Mercury here, and I hopefully today I'll be able to actually get this lower unit onto the motor. We're in mid-October, it's getting kind of cool here. It's certainly cool to be out on the water, but I'd still like to maybe just get the boat in the water and get the thing running and take a spin around the lake one time just to see how it acts. I haven't acquired a 21 pitch prop, which is what more than one person has now advised me to be thinking about. So I'm going to run this damaged prop that's on here now. This is probably going to, if I understand the science of this whole thing correctly, I think this is probably going to spin too fast because of the ratio change, which is going to in turn cause, more than likely, at wide open throttle, it's going to cavitate, not be very efficient. I think that's right. I don't know. But I wasn't planning on goosing this thing anyways. I just wanna, see how it acts running around the lake, maybe at half throttle or something like that. And also, basically, wet test this lower unit. So one of the things I got to do before I put it on is I'm going to pop the cover off of this water pump here, and I'm going to take a look at the impeller that's in there, because I have no idea whether or not this is a brand new impeller. Even if this is a new impeller that was put in here when they gave it this spiffy paint job, the possibility is that it's a brand new impeller that sat in there unused for so long it might be in bad shape. If it is in bad shape, I'm probably going to, if it's in really bad shape, I'm probably going to use the impeller that I took out of the original unit that I had, because that impeller actually looked like it was in pretty decent shape. I think it had not been replaced that long ago. So we'll just zip the nuts off here and pop that cover up and see what we can see. Alright, I just removed the nuts that hold this cover on, and just like the other one, this is one size and this is another size. I don't remember this screw right here being on the other one, and this is kind of weird to me. That's the kind of thread that you're like on a lag bolt. So why the heck, what are they using that screw for? I put the other water pump parts away already, but I don't remember having to take a screw out like this. Yeah, maybe it's just because it was a little while ago and I don't remember. You can see how the shaft moves up and down. You'd think that'd be a problem, but that's the whole purpose of that spring-loaded pin on the top there, is to keep it down and preload it up against the bearing. Kind of a weird deal there. I've heard some people say that they believe that these units that had this design weren't as good as the other type, but I've also had people say that they've had absolutely no problem using this type, so go figure. Well, I can see I just tore either the gasket was already damaged or I just tore the gasket, which I was hoping to avoid doing because I wanted to reuse that gasket. There's grease in there, that's a good sign. Got quite the curl to it. See how that looks up against the other impeller. Well, I'm not impressed with either one of these impellers. This one on the right is the one I just took out of the lower unit that I just got. Okay, and it's got a little bit of deformity around here, but that's not what concerns me. What concerns me is the pronounced hook on all the blades. You can especially see like on that one there, and that's just from it being parked in that position for a long period of time. This one actually is the one I took out of my original unit, is actually in much better shape. This blade here has quite a curl to it, and you can see that like that blade and that blade there have almost no curl to it. So this is where it was parked, on the short side of the housing. So for those of you who don't know how these water pumps work, essentially what you've got is this hole that the shaft goes through does not come up in the exact middle of that housing. It's off center in the housing. And what happens is these blades, the tips of these blades are going to press up against the inside of that housing to make a seal. And as they rotate around, they actually, when they come around to the side where this edge of this diameter right here is closest to the outside diameter of the actual housing, things get squashed down. And what that actually causes the water to be forced out of this pocket. So essentially what happens is, as this comes around, it comes around on one side, water flows in, and then as it passes the opening that it flowed in through, the water ends up being captive in here. And then as it comes around to the side that's closest to the outside diameter, and these get pushed down, they actually end up pressurizing that little bit of water in this cavity, so that when it comes to the outlet, it wants to be pushed out. And that process is just continuously going on. So I don't know if I probably didn't illustrate that very well. So this is the inside of my original housing, and you can actually just about see there's a perceptible difference in the width of this side to the width of this side. So you can see this side, from this inside edge here to here, that diameter is smaller. I'm sorry, that distance is shorter than the distance from this edge to this edge. So what happens is, when this impeller is in there, okay, and it's turning around, what happens is, when it's over here on this wide portion, okay, that's where it's over where the water basically comes up into the pump, basically through just atmospheric pressure, because it's submerged, the drive, the lower unit's submerged underwater. So water is more than happy to flow into that void, and as this rotates around, because the fact that it's narrower on this side, these blades get compressed, and actually this little volume decreases in here, which increases the pressure, so that when it comes around to this point, by the time the water in this little compartment gets around to here, it's now being pressurized, and then it passes the opening where the water is going to be pumped out, and at that point it is forced out. So interesting thing about this is it's kind of funny how the design is. You'd think there'd be an opening here, but there isn't. So it actually goes through the bottom part of the pump there and makes its way up. But anyways, so this is happening constantly. It's just a constant cycle where the water is entering here, coming around, being compressed, and exiting around this side. Okay? So hopefully that was a half intelligent explanation of what's going on in that thing. Oh, so what happens is, when these impellers sit for any period of time, for instance, like the entire season that your boat's off season, when your boat's not being used, which, if you live in a cold climate like New England, we've got more months of the year where your boat tends to not be on the water than months that it tends to be in the water, especially if it's a pleasure boat. Bass boats, you run them longer because you're going to fish for longer. But I'm kind of getting off subject. So anyways, it sits for a long period of time. The rubber tends to, as it ages, lose some elasticity, and that's why you end up with a situation where, when this impeller is taken out after being in there in one position for a long time, you're going to have some of the blades are going to be more pronouncedly bent over than the others. And the ones that are more pronouncedly bent over are the ones that were sitting up against that short side of the wall in there. Okay, now, this impeller was with this, Now let's look at this cover. Okay, now remember I told you about the design of this pump, how it's supposed to work. Okay, well, if you look carefully at this cover, you're going to notice something that I noticed. All right, which is, remember that this hole is off center from this diameter. And if you look, it's been installed incorrectly by the looks of it. I'm no expert, but that's actually the plastic of the housing right there that you can see. Okay, and because of that being off center, since the plastic is showing here, if we look at it from this side, you can actually see the metal lip sticking out here. So when this housing, this replaceable housing right here, is installed in the plastic cover, okay, of the pump housing, it has to go in a specific way. And there's actually a little indentation right here, which I think is like a tab, that's actually supposed to probably line up with something, and that's what makes sure you have proper alignment. And I could see that if I compare it to this one, okay, notice this one is in so that the wide side is over on to the left here, and the narrow side is to the right, and that tab is way over here. And if you look at this one, you'll see that, well, the narrow side's more like up here. So this whole part right here, sorry, let me widen that angle. All right, so this whole part right here looks like it's turned, about 40 degrees too far this way. Now, whether or not that could actually spin on its own and cause, could that have been caused by just it moved when it wasn't supposed to? I'm thinking there's got to be something in there that keeps that from moving. It's going to take a little bit of prying to get that out. Yeah, there you go. There's a indentation right in there. Alright, so right down inside there you can see there's a little hole, little notched hole area right there. And on top of this housing right here, there is a tab that on this one appears to be maybe pushed down, maybe more than it should be. So yeah, looking at it from the side, it's pretty much flushed. So what happened was, somebody didn't know what they were doing, I think. Put this in incorrectly and just tightened the cover down, and in the process of doing that, probably crushed that tab flat. So they didn't notice that there was an alignment here. I'm curious what the heck that did to the characteristics of the efficiency of the pump. You can just imagine. The guy who sold me this said that, they were an OMC dealer, and they had taken this in. They had taken this outboard in at trade or whatever. They had probably put a new outboard on the guy's boat for him, sold him an OMC or whatever they were dealing, took the Merc off, and he said power head was junk, and they took the lower unit off before they trashed the power head. Well, I wonder whether or not that power head failed because of this water pump not pumping water properly. Who knows? We may never know, but it's kind of interesting. I don't know. I found it interesting. Maybe you guys won't find it. The other thing is, this thing being off kilter, it was so far out of whack that the shaft was rubbing against this metal and actually deformed it. That hole is no longer round. And you can actually see there's, it's going to show up, but there's actually a metal lip that's raised right here. So this thing was pushing on that shaft until the shaft finally was able to wear or deform the metal out of position. So you can imagine that's also going to be an issue. Now I just checked the shaft and there is a groove there. I don't know if it corresponds to where this was. So I just installed the cover. Now the other thing too, with that tab being pushed up and everything, this cover probably wasn't fully seated. Wouldn't be surprised at all if there was an issue with getting the thing to seal. So anyways, I put the cover on and look at where that lines up with that, where it corresponds, and you can actually see there's a line right there. I can feel it with my fingernail. There's a little bit of a ridge right there. But still a lot better than the shaft on that other unit. So there's the top of the key right there that the impeller is engaged to. So there's where, right there is where that cover was rubbing. So what I decided I'm going to do is I'm going to reuse the better of the two impellers, and I'm going to use my original cover because it's not all burnt up. The other interesting thing is, I don't know if I mentioned it already, but the rubber bushing or seal that's down in here that the metal copper pipe inserts into and helps seal this connection right here, it's totally missing on the other one. So I don't know what the deal is with that. So let's see. We're gonna. I've got a gasket that is still in pretty good condition from the original pump that I took apart. So I'm going to use that. I got to make sure this goes on. You can see the little curl in the fingers there. This goes clockwise, so it has to go on this way so it turns like this. Because if you put it on backwards like that, what will happen is when it's trying to turn, is these will try and fold over on themselves, and that's not good. Right, that keyway lines up with that blade, so that's a pain. Now to assist in getting this cover on, I'm going to put a little film of grease on the inside of this cup. And by putting that film of grease on there, I should be able to get this cover to slide over the blades of the impeller a little more easily by, as I push down on the cover lightly, I'm going to turn it clockwise. There we go. Now the important thing to remember is never ever turn this shaft counterclockwise. Alright, I just tightened down these nuts and this screw, and I'm going to reinstall this water slinger, even though it's in a really lousy shape. But it's better than no slinger at all, which is what was on the other one. Okay. And if the test goes well, then at the start of next season, what I'll do is I'll rebuild the water pump, new water slinger, and new impeller and everything, and drain the gear case and new oil and all that. So at this point, I think I'm actually ready to attempt to reinstall it onto the motor. But I'm going to take a break from this right now because I've got a flea market finds I've got to do. I've got all my stuff that I picked up at the Quabog Valley Engineer Association's fall tractor show and flea market, and I wanted to get that stuff put away, so I'm going to get to that next.